and welcome to today's NCCR news and tutorial.
Wow.
Yes, it's like country and western.
Hello.
Hey, we'll be talking about this.
And a lot more.
Yes, it's gonna be quite a lot of info and quite in detail. So we were joking before, like if you don't have the attention span, then maybe watch it another day if you don't have the time right now.
Yeah, exactly. Because now we are going in the details of the chain alignment and the chain slider eating saga on the EBR 1190.
And this is the little guy that will help us for that. I hope you can see the laser.
Yeah. So Julia and I, we develop now solutions to fix the problem. And we will take you through the whole process, not of the development.
No, that's why we've been quiet for quite a long time now, because we've been measuring and 3D printing and measuring some more and taking things apart and putting things together.
And then we all need to bring it to your garage, that you understand it and find a proper way of replicating the measurement. And that was the most challenging thing, beside understanding the problem of this multi FU, what the factory have done there. We are still not sure what happened there. We identified some more problems. We will also go through it. So at the end, as a sum of all, I would say, if you change your front sprocket, you need to individually align your chain line correctly, otherwise you can run into problems.
Yes.
So, should we start?
Sure.
Okay.
What you can do is, after you have removed the chain guard, you use a longer M6 screw and you screw it really close to your rear sprocket, but not all the way in. You don't want to block it, but you want to have a little bit of air, and then you run it to see if the sprocket is straight on the wheel, on the rim. And then if you think it's too much air, you can always screw it in a little bit more, but don't scratch it.
Yeah, they're always a little bit wobbly, but there you can immediately find out if you have a bended sprocket or if it is a lot of dirt under, incorrect mounting. That is a quick check to do it.
Yeah.
So we are sticking our 2 millimeter to the left with our swing arm bearing, and we see that this one was not a chain slider eater. Yeah. This overstand to the left means that on the right side our bearing is standing 2 millimeter back. So here now this bearing is sitting on its bearing seat full in. So as we anyhow need to replace the bearings now, kind of rough proof that our bearing gallery can move. We have here now this right bearing standing 2 millimeter in, and remember the other one is standing 2 millimeter out. We have the bushing original between. And now we see with very, very little effort, just some bang with a hammer, now the bearing gallery moved this 2 millimeter to the right. And when we go now here to the other side, we see now that the bearing is in. I could bang a little bit more and then would get even more in. But you see there is no resistance, so the swing arm can move 2 millimeter in the bearing gallery to right or to the left, depending where it is standing. So we remove the bearing. And here's what we are getting out. We have this two 14 millimeter bearings and the aluminium bushing between. And just to repeat it, we have the two bearing seats. On the right side it is a 16 millimeter seat. On the left side it is a 14 millimeter seat. So let's look how that assembly is looking when it is mounted to the motor. So this is how the standard setup look. We have the 14 millimeter bearing, we have the bushing, and we have the other bearing. Put that up now. So here we have the mark, that mark, and this is how it sits in the bike now. So this is the original standard setup, 14 millimeter bearing, the I think it's 108 millimeter distance bushing, and the right bearing. And now a swing arm can move in this 2 millimeter to the right or to the left. So 2 millimeter it can move. And here comes the solution. We have an shorter bushing, 2 millimeter shorter. We have a 14 millimeter bearing to the left, and now we use the 16 millimeter deep bearing seat on the right side in the swing arm, and put there in a 16 millimeter bearing and 40 millimeter to the left. And now we have a correct line up bearing gallery. Now the bearings sitting on the ground of the bearing seat, and now the swing arm cannot move anymore to the right and to the left. There are some differences in the sprockets. What we see, there must be at least 3 generations of sprockets. This is a very early original RS, and this is an actual, and you see that here there are, I guess these are different suppliers. Here you see that this is not machined at all. This here have a bit of a machining. So I guess that some, this is a holy grail, this is the 18, what in real never existed. But what we think is that there is something wrong also in the measurement of the sprocket needle bearing assembly, where some of the pain might come from, especially when your bike had no problems and you change the sprockets and suddenly it starts to eating chain sliders. But this is a theory, and honestly, we are here at NCCR, not the quality department of EBR, and we are just tired to look into that. We find now a way to individually find the position and go from there and adjust it, because honestly, here to start to adjust is everything is possible, but this is not really practical.
So the way that you use these gauges are you try to align as much as possible with the engine case. So nothing like this or that or weird, and be very careful that you don't end up in here in the round part. So try and align as much as possible with as flat as possible. And then you can see, turn this a little bit, and you see this one I would measure to 25.5. And now we look at the other engines that we have standing and compare this. So same thing again, try to align as much as possible, as straight as possible with the engine case. And this one would then be 26. And now we look at a couple more.
What was the other one?
25.5.
So there we have 5/10 different, a half millimeter difference between the bike we have on the bench and this motor.
So this one I measured to be 24.5. So in between these 3 engines we have a difference of 1.5 millimeters. And another way to illustrate that easily is if you just take these ones. So over here, that's the second one we measured. This 1.5 millimeter fits in easily. And here, not a chance. Yeah. The 1 millimeter just exactly goes in. So you see there is quite a big difference between the different engines.
And 1.5 millimeter is chain line difference on 3 different motors, and they are all out of the same time. So in real, I guess out there might be even bigger differences, because here at least the sprockets came out of the same manufacturing batch as I see it at the moment. So yeah, now we know how to measure the positioning of the sprocket to the engine case. see? So this is just 100 kilo, and we see that it is nothing sticking out anymore. Here I even already feel an edge that the sprocket assembly is already a little bit deeper in it. So that way I would say we can be sure that there is not much Cush drive movement going on.
So we're going to give you a little overview. This is our chain alignment tool. So here you have the laser. You can see it a little bit there. This one goes on the rear sprocket. So you have on the inside, I printed it that it will perfectly fit on the rear sprocket. And here you see the target, the white one. And the idea is that this one sits on the front sprocket, so you see it has also the waves on the inside, so it will perfectly sit on the teeth. And then depending on how your rear sprocket is located compared to your target, you will see it differs, and you have the middle line. And I also constructed that way that you can throw the laser line over the hole, and here in the end you also have a little cutout, so you know also it's the middle of the part, and this part sit exactly on top of the middle of the sprockets, because you have the sides that are a little bit longer, so even if the sprockets are a little bit used, they will still sit exactly on the middle of them. Then you have here the distances. So this distance you use to see how big the distance between your front sprocket and your engine case is. So you have 24, and then you go a half millimeter step, 24, 24 and a half, all the way up to 27. Next is the distances that you will use to align your swing arm. So it's 4 different of them. You go from 0.5 up to 2 millimeters. Then you have the 2 different bearings. It's 14 and 16 millimeters for the swing arm. And then you have a shortened swing arm bushing. And now we will show you how to use all of these. So before you start measuring with the laser or look with the laser, you make sure that your wheel is in straight. So you measure to the end of the swing arm, and you see that it's on both sides the exact same measurement. Then you have put on the orange, the holder of the laser, and the white one, which is the target. And if they are on straight, you can see that you throw a line over. This one is also the middle line that you see in the part, so it's the cutout in the back and the cutout in the front. You see here that it's in the middle. And this is how you know that you have a straight chain line.
Yeah, what you can also do then, you can go a little bit right and left, because there's always a little bit of imperfection in the whole drivetrain, because you need to understand this is nearly, this is more than a meter of distance now, but this is how you find the alignment. And the interesting thing is, on this bike now, the chain alignment is correct.
Yeah.
It was, but this bike there, the left bearing is looking out 2 millimeters out of the swing arm, so we will correct here the swing arm gallery, the bearing gallery, and we take out now the swing arm and put the other bearings in.
Yeah.
There we see how easy. There you see when a bearing is sitting only with less than 10 millimeter in its bearing seat, the swing arm bearing, then it starts moving and then it fucks up the swing arm. That is the reality. Bang. So this bearing was sitting roughly 9 millimeter in its seat. That's it. Here we see how happy a bearing seat is when on one side the bearing is hanging in the air, and on the other side in real it is not better, because here we have a seat what is 60 millimeter and there was a 40 millimeter bearing in, so here we see it also that there was some movement. So now we installed the first bearing. This here it's the left one. Make sure that it's sitting 100% on the ground, and we install the distance bushing what is 2 millimeter shorter. Either you shorten yours or you got a new one from us. And now we double check that we are 100% sure that the bushing should be just a little bit higher than the ground where the bearing sits on. And now with the bearing installation tool, we install the other bearing, and then we are good to put it back. So we start for the first try with a 1.5 millimeter distance to the left, and then check if our chain line is then correct or if we need to go bigger or smaller.
So now the distance is in place, but the axle is not tightened down yet. So you see you can still move it. And the way we orient is that we shove it all the way to the front and make sure that it's all the way to the front, and then we tighten the axle and then it will stay there. So once you have mounted back your rear wheel, you of course check again that it is mounted straight. So you check on both sides. In our case that's 30.5, but it will be different. That's important, sorry. Torque after spec, the rear axle. And also don't forget the brake caliper, because then you will have a totally wrong distance. And then you will put back your laser, and you see here that it is aligned and nice. And also you can check that it is parallel. You see here with the second cutout, see that it is really true, so it is in the middle of the target. You see that. And also if you have a used rear sprocket, we place it on several different spots across the sprocket. And so we marked it here, so this is where we started, and then we check it in some different spots on the sprocket, because I mean you never know, it could be a little used, it could be a little weird in a way. It's also what we saw in the beginning when we used the screw. And if you now would see that your line is a little bit too far out or a little bit too far in, you use another one. This one we have in now is the 1.5, but if it is a little bit too far to the left, you will use a smaller one. So you would maybe go down to 1.0 or even 0.5. And if it's the other way around, then you go bigger. So now that we have gotten all this information, I mean, it is kind of a lot, but we hope that you did have the attention span for this, and now you know how to use these. You know why these are important and why this one is also your best friend in case you get a new front sprocket. So of course you measure your old one before, then you mount the new one, and then you measure the difference, because then you know if and how much you need to change these again. And we've learned a lot about all the different Cush drives and why it is kind of a pain, but we will now torque everything to spec and put it together according to manual, and then we'll see each other again. Okay. So now you have learned a lot, and I hope that we made a lot of sense to you too, and that you could follow along and now are able to use both this part and that part
understand why you need the distance on the swing arm to distance it out to the individually chain line of the day.
Yes. So
what a mess.
Yeah.
Okay.
Well, please stay on target. Ha ha ha, he asked me to make a funny joke.
That was a low-rider joke.
Yes, that's the best I could come up with, sorry.
Thanks for watching. Thanks for buying our products, because if you don't buy, then we don't need to do it.
Yeah.
Because at the end, it's all about someone pays the bill. And
food in our fridge.
Thank you.
Thank you. Have a nice day.
Take
Bye.
care. Bye.